Okay, and welcome back to track one of the first ever virtual software circus. We have an old friend of mine, Luke Marsden, with us. Hey, Luke.
Hello, how's it going?
Very well. I'm enjoying the outfit.
Thank you. I'm trying to make the ears fit above my head. I don't know if you noticed.
The other way, you can get a hat as well, it looks like. I'm going to give a quick shout out to our sponsors and then we can get started. I'd like to thank Packet, Container Solutions, Rancher, OfferZen, the CNCF, Honeycomb, Aqua Security, Kinfolk, Giant Swarm, and CloudBees. You can go meet all of those lovely people in the sponsors tab where they will have people live chatting to you and they've all got excellent things to give away. Now, Luke's here to talk about MLOps through the looking glass. I'm going to get out of your way and let you do that, Luke. But first of all, you need to have the same treatment every other speaker has had, which is some canned applause to welcome you to the stage. Here we go.
Yay! Woo! Thank you. Well, it looks like I forgot my own talk title, so I named it MLOps Through the Rabbit Hole instead, but that'll do. I've also got a teapot here, which Zoom doesn't think exists. Oh, now I don't exist. I didn't know what I was going to do with the teapot, so it's my prop. But anyway, so I'm going to talk about MLOps Through the Rabbit Hole or the Looking Glass. And so I'll start by talking about, well, what is MLOps? And the punchline here is it's the intersection of these three things. It's a combination of DevOps, software engineering, and machine learning. So what I wanted to start by doing was to say, well, what's the state of the art for these three disciplines, and then we can talk about how we combine them and what the challenges are when you try and do that. So kind of the state of the art in software engineering is obviously not what we see in the picture here, but it's the history of how we got to where we are in terms of machine learning is that we started out on these big multi-user mainframe systems with punch cards and early versions of Unix. And then we moved to a world of personal computers that were networked to each other. And the way that software development was done kind of back in the day was that people would email each other patch files around. And so this was how the Linux kernel was developed for a long time, was that people would maintain their own local source trees and they would email each other kind of diffs of how to change the source tree from one version to another. And of course, that had some challenges associated with it. Not least the fact that it was a very manual process. And so when tools like Subversion came along to enable centralized version control, they allowed people to check in and out versions of a source tree and have branches and things like that. That was pretty much a game changer. And the next level beyond that was distributed version control, which was enabled by Git and GitHub, which enables this kind of social aspect to coding where anyone can fork anyone else's project and push and pull and so on. So that's kind of, in my mind, kind of the pinnacle of, or at least one aspect of the pinnacle of software engineering is distributed version control. So that's software engineering. It's how we write code. How do we deploy software? And so this kind of DevOps journey has been similar. I am personally guilty of editing code live on the server. I don't do it anymore, but I used to do that when we used to run PHP web applications. There was kind of the bad way of making changes was just logging into the machine and changing the code. And obviously that was insane. It doesn't scale to any number of users, and it only works if you're really a kind of a hobbyist. And then like maybe a step beyond that was building binaries and emailing the binary artifacts around. That also doesn't work very well. You've got this kind of silo that you end up having between dev people and ops people. And I know that the audience for Software Circus here is very familiar with this notion of DevOps to break down that silo. And another aspect of breaking down that silo between dev and ops is continuous integration, so that it's possible now to automatically have your code tested whenever you push it. Another big kind of change in the world of DevOps was the move to the public cloud. It's become very unfashionable to run your own servers anymore, and it's much better to let someone like Google or Amazon or Packet run your servers for you. And it's also there's also been, as well as letting someone else run servers for you, there's also been this big move towards consuming APIs as a service, and consuming kind of higher level services. There's also been this move to immutable infrastructure more recently. And what I mean by immutable infrastructure is this whole world of Docker, which means that you can package your application up along with all its dependencies, and move that around so it runs in exactly the same way on your laptop and in production and so on. Kubernetes is a way of running lots of Docker hosts in a cluster and staying sane. And more recently, there's this notion of GitOps, because I talked about sort of version control and Git in software development, but there's this notion that you can also use version control to keep track of your immutable infrastructure. If you've got a tool like Terraform, then you can version control your Terraform code, and you can review changes to your infrastructure as pull requests. And that notion, and also not only infrastructure, but also the application code, the application configuration in Kubernetes YAML, is a key part of that kind of move to immutable infrastructure. And so there's this other aspect that's really hot right now, and that is machine learning and AI. And so machine learning and AI is really how we use fancy data and fancy maths to train models to automatically predict things that otherwise might be a manual process. And it's basically about being able to expose an algorithm to a data set and have it learn the pattern of that data set, so that when it's given new instances of things like that, like images, it can, say, classify them. And so the history here, just really quickly, is kind of back in the early days of Pythagoras, a long time ago. Kind of the pre-computer mathematics of this was around kind of curve fitting and linear regressions. Like, can you match a function to the data that it's looking at? Much more recently than that, there was kind of in the 60s this notion of Markov chains and this early concept of neural networks, which led to this first AI winter. In the 60s, there was this huge hype around AI, which kind of feels a little bit similar to the hype that there is today. But where it fell down in the 60s was that the computers just weren't powerful enough, and there wasn't enough storage in computers to really make use of, to actually make accurate machine learning algorithms. So algorithms like backpropagation, this whole move to a data-driven approach, enabled AI to kind of come out of this AI winter. And as Moore's law accelerated, and as specialized hardware came available for doing deep learning, like GPUs and IPUs, this image here is from a company called GraphCore here in Bristol that make IPUs, for example, and they make these beautiful images of this is actually what a neural network looks like structurally. It made these advances in the hardware are making deep learning computationally feasible, and so it's possible to have these big fat neural networks that are exposed to lots of training data and actually start giving sensible human-like results. So that's fine, and those are these kind of three pieces. But the rest of the talk is going to be about how do you put them together. And so what we're seeing is that machine learning and AI, I'll use those terms kind of interchangeably, as machine learning is emerging from research, and it really is, it's suddenly every enterprise on the planet is in an arms race to try and find ways to get value out of AI and ML. So all of these companies all over the planet, from everywhere, from Netflix to like big and like stodgy old enterprises, they're all trying to figure out how to get value out of this stuff. And the problem is that you can't just have machine learning on its own. You can't just have machine learning algorithms that are created on someone's laptop. You need kind of the quality and the process around software engineering you need to be able to, because training models involves writing software, and so you need best practices and discipline around that. You also need to deploy these models into production, so you need DevOps, and you need the fancy maths and the algorithms with the actual machine learning. And it's this convergence of disciplines that will and is called MLOps. So that was a very long way of defining what I mean by MLOps. So now let's talk about AI and how it can change the world. So I do believe that AI has the potential to reinvent the global economy. I think in a quite a futuristic way, it could mean that a lot of humans do a lot less tedious work through automation. And of course, there's a lot of political complexity around making that work in a way that doesn't leave millions of people jobless. But I do believe that there is real kind of human value to have to get out of AI. But what we're seeing is that as a discipline, it's really immature. It's kind of like the Wild West out there in terms of AI. And actually, hat tip to Mark, because Mark and I wrote an early version of this deck together. So I just wanted to give Mark a nod there. So what we've seen at Dot Science is real damaging levels of chaos and pain, trying to operationalize AI, trying to go from that level of I'm running this on my laptop to I've got a scalable process for running this stuff in production. And so there's an interesting parallel here, which is if you think about the history that I described of software engineering, the software engineering in the 90s, that kind of pre-version control software engineering feels a lot like where machine learning and data science is today. Because in data science, there's no version control for data most of the time. There's often no continuous delivery. If you've got data scientists building models on their laptop and it's just file soup for all of the data that they're using and the versions of those data that they're using, then they're emailing a Jupyter notebook to their DevOps people or their IT team, then you're in exactly the same place that software was kind of back in the 90s. And what we saw with DevOps was this possibility to switch from software taking months to ship and then shipping in minutes, and apply that same kind of paradigm shift to AI and machine learning. So yeah, that's kind of the high level stuff. I want to talk for a minute about the concrete, specific problems that we've seen in this industry that are solved by this MLOps approach that I'm advocating. So the first problem is that, like I said, if you give an ops person or an IT person a Jupyter notebook, they're just like, what the hell is this? I don't know what this is. How do I deploy this thing? And so there's the kind of a language barrier between the data scientists and the IT people often in organizations. And we've spoken to hundreds of enterprises that are trying to deploy AI and ML. And actually their number one problem is that most of their models don't get deployed. And so even when they are able to deploy model, they come across this problem number two, which is it's really hard to monitor models. Monitoring models is different to monitoring microservices, and then kind of those are the kind of the first order pain points. The second order pain points are then around, well, my team ends up spending a lot of time wasting time trying to get a development environment set up in a similar way to my colleagues. There's inefficient or even absent, completely lacking collaboration. Often data scientists are given one problem and told to just work on that thing. And if they walk out the door, then a lot of knowledge has left the building, metaphorically speaking, these days. And this lack of collaboration is worse in the COVID era, of course, because now everyone's working from home. And so if you used to be able to get away with collaborating and keeping track of your work with a whiteboard or by being in the same physical place, you can't do that anymore. And there's a lot of manual tracking that we saw as well. We've seen an awful lot of companies using spreadsheets to keep track of models. And if you said to someone in DevOps, like, oh, we use a spreadsheet to keep track of our deployed microservices, they'd be like, what? We have a CI system for that. We have Kubernetes and version controlled Kubernetes manifests, but we saw this a lot. And this led on to this other problem of a lack of reproducibility and provenance. So I'll talk about what I mean by reproducibility and provenance in the context of this manifesto. So we came up with this MLOps manifesto, and by MLOps we mean DevOps for ML. Really, it's DevOps for ML plus software engineering. Models have to be reproducible. That means that I have to be able to take a model that Mark built 9 months ago and retrain it to at least a few percentage points of accuracy. I also need to be able to keep my models accountable. That means I need to be able to go back from a model that's running in production to find out what data it was trained on. And this is especially important in regulated industries. Model development has to be collaborative, and I'm quite opinionated about this. I believe that you should not be editing your Jupyter notebooks, or you should not be editing your notebooks using Google Docs style collaboration, because reproducibility is hard enough in notebooks already without having multiple people changing the same thing at the same time. It just becomes insane. Whereas if you treat data science projects and notebooks in the same way that GitHub allows you to treat repos, where you can fork things and make pull requests, then you're going to have a much better time. And then finally, model development and deployment has to be continuous. That means you have to be able to continuously deploy your models and also statistically monitor them. Now, statistical monitoring is an important point, because you can't monitor your models in the same way that you monitor microservices. With microservices, you can look at things like latencies and error rates, and if those look normal, then you're probably fine. Whereas machine learning models can be reporting completely normal latencies and error rates, and they can have actually gone completely haywire. So that's a real problem, and the reason for that is that you might deploy a bad model, one that doesn't behave as you expected it to on your production data, because your production data is different to your training data, or the world changed. And so if you have an autonomous vehicle model, for example, you've got an autonomous vehicle that's driving around using its camera sensor to classify road signs. Maybe you'll find that the number of classified stop signs drops to 0, and that might be because suddenly it snowed, and the machine learning model, the computer vision model, wasn't trained on any images of stop signs in the snow. And so there's all of these weird things about models that mean you have to be able to monitor not just the latencies and the error rates, but also things like the statistical distribution of classifications that a model is making, or the drift in the data that's going into the model. So you can see when a model is kind of operating beyond its tolerances for the kind of data that it was trained on. So that's our manifesto, and this is kind of what we believe in. And the specific insight that we've had as well is that the software lifecycle is much simpler than the MLOps lifecycle, because in software you've got code, you test your code in CI, you deploy your code, you monitor it, and you go around this loop as quickly as you can. And then with machine learning, it's much more complex, because you've got data coming into the system, and data is a source of entropy. And you've also got code, and then you've got the parameters that you train your models with. And that generates these model runs, which is the execution of a specific piece of code against some input data that generates a model. And similarly, you have data runs, which is a sort of data engineering step, which read some input data and created some intermediate data. And so what we found was there's this kind of paradigm shift. If you stop thinking about just versioning specific pieces of code and start thinking about tracking the executions of certain versions of a piece of code against input data and creating output data, then you can get to a place of much greater sanity, because all of these variables can then be packaged up into a run, and the run can contain metadata about everything that went into making that piece of data engineering or that model run reproducible. And then the model artifact itself is the thing that, inspired by the data it was trained on, can be deployed into production along with tracking the metrics not in a spreadsheet, deploying that model into production and then monitoring it for this sort of statistical behavioral changes. So that is that's kind of the key idea that we ended up with at .science. And so I just wanted to take a few minutes talking about our journey through through this rabbit hole of finding product market fit. So back when we started, coming up to 3 years ago now, we started with a different thing. It was a thing called .mesh. And the idea with .mesh was that we were going to solve data versioning for DevOps. And so we had this this concept that if you could snapshot and package up the data that went into your development environments when developers are building microservices-based apps, and you could snapshot your databases and your queues and your key value stores, and then move those runnable snapshots of your application, including their state. If you could move them around, then there must be all sorts of interesting applications for that, like runnable bug reports. So if someone manages to reproduce a bug in a development stack, then you could attach that bug report, or attach that runnable snapshot to a GitHub issue, for example. And so we started out with this notion of data versioning for DevOps, but within 6 months, we realized that there was actually a much bigger opportunity around data versioning for machine learning. And so we pivoted the .mesh tool, and we used that as a foundation for building the .science platform. And we started out doing data versioning and provenance for machine learning, and we added Jupyter support and so on. And then, quite honestly, we spent about a year trying to sell this thing, trying to do enterprise sales. And what we learned from that year, kind of between summer of 2018 and summer of 2019, or early 2019, was that we were having an awful lot of conversations with potential customers who said, "Thank you for teaching me about a problem I'm going to have in the future." And what we also heard was what I said at the beginning, which was that people were having these more fundamental problems of needing to be able to deploy their models at all, and having a sensible way that data scientists can easily deploy models into production, and also to monitor those models once they're running in production. And so we went end to end with the platform, and as well as having this kind of data versioning, provenance, collaboration, and model management piece, we also added the ability to deploy and monitor. And what we found then was really interesting, was that we actually did achieve product market fit with the end-to-end piece. And we went from a pipeline of basically $0 at the end of 2019 to in the summer of 2019 to a significant kind of multi-million-dollar pipeline, and we closed 3 customers. But yeah, I also unfortunately today, and in fact yesterday, we announced, so some people who are watching this might already know about this, but unfortunately, as of yesterday, it's official that it's game over for .science. As I said on Hacker News last night, we ran out of that crucial currency of investor patience. And so I hope that this talk might share what we've learned with people who are interested. And I did want to also share that on this blog post, if people haven't seen it yet, we've got bios for everyone who was involved in the team. And there are some truly wonderful people here who are now looking for work. So if anyone who's watching this might be interested in talking to them, then please email me, luke@.science.com, and check out the .science blog for this list. And the other thing that's continuing that I'm really happy about, that is kind of surviving the closure of .science, is this MLOps community website and space that we created to discuss MLOps. And my colleague and friend Dimitrios and Chris, they are keeping this thing running. And so we have meetups every Wednesday at 5 o'clock UK time on Zoom, 9 a.m. Pacific. And we're modeling the MLOps community a lot like a Kubernetes SIG. And when we started with MLOps community, we talked about wanting to make it a vendor neutral space. And I think that now .science is shutting down, we truly can make it a vendor neutral space. And so what we're seeing is a lot of growth in that community. And I'd encourage anyone who's interested in this stuff to come along and get involved. Join the Slack, which is linked to somewhere around here at the bottom, certainly in the footer. Yeah, there's a Slack link at the top. So come and join our Slack and hang out with us. There's also recordings of all of the meetups that Dimitrios has been running. So yeah, there's a wealth of fascinating content on here. So come and check it out. And with that said, I think I've got 3 minutes left, which might be time for any questions.
First and foremost, it's time for a big round of applause.
Yay!
Thank you so much for that, Luke. I just tweeted Luke Marsden giving I can't remember how I put it, a very open and honest journey of a startup at the Software Circus, one that I'm honored to have been part of. It's lovely that a lot of the content that was generated is going to remain and be useful for people, and that community is going to continue there. We're basically not getting any questions. We're getting well wishes. So,
okay.
Hug ups.
Oh, thanks.
Alex says, sorry to hear about your news with .science. I'm sure you'll have a lot of offers coming soon. Jonathan Giddy says, thanks for giving a talk at a difficult time. Best wishes to the whole team. Alex has a question. It might not be what you want to talk about right now. Alex is asking if you've got any tips around qualifying leads for enterprise sales. This is something that's close to both of our hearts, Luke.
Yes, well, I can attempt to talk about that for 60 seconds. So one of the experiences that I was lucky to have in .science was learning how to do enterprise sales, and I think that you're kind of in the same boat there, Mark, probably.
Walter.
And we had this, Walter. So we had this awesome sales coach from California, namely Walter Roth, and he taught us about the importance of understanding the 3 Ws. So when you're qualifying an enterprise prospect, talk is cheap, right? And you can get very excited about someone who wants to talk to you, especially if you're a startup that's like desperate to talk to potential customers. And as soon as someone starts talking to you, you get very excited and you start thinking, oh, there's like an 80% chance that this person's going to buy a $500,000 contract or something. But it's very easy for people to be friendly, especially if they are interested in the area. But if you haven't got answers to the 3 Ws, then it's never going to happen. And the 3 Ws are why buy anything, why buy us, and why buy now. And so why buy anything is what's your pain? Like why would you part with cash? Are you going to make your team more productive? Are you going to solve some big problem? Are you going to stop your models going haywire, which is costing you money or whatever? Like it's basically a business reason for why you need a solution to a problem. Why buy us is the competitive landscape. It's like, why would you buy your thing instead of all the other things that are available on the market? Because any reasonably sensible enterprise buyer is going to look at the other options on the market. And so you can't just pretend that they don't exist. You have to really understand where you stand in that comparison. And many enterprises' procurement departments mandate it, that you've done some level of due diligence on the rest of the space. And then why buy now is what's the compelling event? Like who's going to get fired if you don't get a solution to this? Or what is it that's making this urgent? And some of the why buy nows that we had in the latter days of .science were, we need to get this model into production in Q1 because we prototyped it with this janky thing which we wrote that involves maybe copying models to S3 from my laptop. And now the business says, great, let's put that into production. And so that was a compelling event. Yeah, I hope that answers the question.
I think that both answers the question and brings us to the top of the time. So Luke, thank you so much for making time right now. As Alex said, I'm sure we're all looking forward to seeing what it is you're going to do next.
Yeah, my pleasure. And thank you for doing a Software Circus. This is awesome. And it's made me really happy in a hard time to be able to get dressed up. So thank you.
That is one of the core ideas of the Software Circus. So I'm glad we succeeded here. Now we're going over to lightning talks. I'm going to be hosting the first one, and then Leon's going to be hosting the second one before we come back with the panel at 6 o'clock if you're in Europe, 5 o'clock if you're in London, and noon if you're in New York. Luke, thank you very much, and I look forward to seeing you again soon.
Cool. Thanks, everyone. Bye.